Hello everyone. So this is our next webinar on the second project, image classification using Pytorch. In the last webinar, we saw how to use the exercises that we did in Pytorch to complete our project. So there I matched the whole segments of the code with the final code that can be used to run the classification on the data set for the part one of the project. So for this webinar, I am targeting the part two of the project, that is checking out, that is making the project in a command line manner where you can pass the arguments like directory, training and testing directories, and all those arguments like GPU enabled or not, or the architecture that is being used. Such kind of things you can use in command line, and that will help us shape our project in a application based manner. So anyone can then use your script for training and prediction, and using the parameters that one chooses to use, and then the inside the code will be the same that you have done in the first part of the project, and that way the whole application will be run, right? So let's first see, let me share my screen and then we will see what all we have to cover today. Okay, yeah, I think I am sharing now. uh, First let's see what was discussed in the last part. Okay, okay, so this was my project overview part here. So yeah, okay, so here I use those exercises, uh, which could be then filled up in the main project. So we have all the blocks ready. We just need to assemble them in the final project that we discussed in the last part. Today we'll be going to the second part that I briefly discussed at the end of the last video, right? So here, there I told you how to use the argument in a Python script, right? So let's see how it can be used now. Okay, let's first go to the project itself. So it says that uh, now you have to make it the project in a command line application manner. So you must have train.py and predict.py in your submission. In the train.py, there will be some basic arguments like data directory. So this is the name. This becomes the mandatory argument that we are going. So there is one mandatory argument that we can choose to use, and then there are others are like optional arguments that have a name associated with them. Like save directory is the name associated with the save directory argument, and arc is named with the architecture that we are going to pass. Similarly, this setting hyperparameters, and other file is predict.py, where we will be passing the path to a single image, and the function will be, so the script will run and tell which is the class of that particular flower. Okay, and so here is a very nice tutorial on arcpass. Okay, so you can choose to go through it. I will first let's see. Okay, so let's see what all we have covered in the exercises. So we did cover all the implementation part. We took the transforms. We loaded the network, and then we shaped our classifier with it. And we also did the processing and training and testing. Yeah, but we did not do prediction last time, right? But this the project says that you need to have a predict.py. So let's first then build a function for prediction. Okay, um, prediction function. This you can. use in the final predict.py also. Okay, let me just get them. So predict.py will be having a single path to the we'll be having a single path to the flower, and then we will try to find the class associated with that flower. Okay, so let's just go on to def predict image path, saved model, and top k. So I guess it was 5 in the project. I don't remember. Uh, I saw it somewhere. It was set to some value. Yeah, I'll just go to the part one of the workspace and then we'll see. Okay, we'll have to see which all parts are missing in the part one, and then we will cover those parts here today. So that will complete your project. To from my side, then you need to just try to submit it. All loading is done, building and training classifier is also done. You just need to copy paste it from your exercise to here, and saving is also done, loading is also done, image processing is also done here, right? Image showing, class prediction, yeah, this what we are doing, right? So image path, model, and top k. Okay, image path model. Okay, so this function we have to fill here. So if you have not done it here, then you this video might be quite useful to you. Okay, so let me load the model first. Okay, so I do it like this. Okay, now set model to evaluation mode. By doing this, we are telling the model that we are not training anymore. Okay, so we are just using the model to check on our value. Just add some clause so that it comes up. Okay, yeah. So now we can use processing the images. Okay, so for processing, we already have this function that we did use earlier. So this is our process image function, right? So you just need to call it. Okay, from here, process. Let's just use this as return process image. Okay, pass on the image path. It will read itself, and then it will tell you the value. Then convert, this part is very important. You need to convert image from py numpy array to the pytorch, right? Numpy array to tensor or torch image, right? Torch image uses a tensor only. So yeah, just write tensor. Okay, torch images torch dot from numpy. So this function you can check out. This is quite common function which we use in pytorch, right? Dot numpy. So let me check torch dot from numpy. Yeah, it's like this. Okay, torch dot from underscore numpy. Yeah, and then I write np dot expand dimension process image access equal to 0, telling it to use the rows dot type. Now telling it to use torch dot float tensor CPU, right? Here you can use GPU also. I am doing is as CPU because this is only single image, so we do not need that much processing power in it. Okay, CPU will work fine. Now we will having probabilities in the form of logs here when we pass our image to the model, right? Model dot forward Pytorch image. Now let's convert the probability back to linear. So it is already in the form of log. If we do it in the power of exponent, it will convert back to the linear. Convert the probability back to linear. Okay. So probability dot log probability. Right, it's working fine. Now to get the top k class, so top k class tells you uh, the top k classes which are having the highest probabilities of being assigned to this particular data entry, right? So get the top k classes, right? So top props, top labels, linear dot probability. Okay, so it's underscore, I guess. Linear probability dot top k is the function here, right? So we will just use this argument. Okay, so this is in a form of number, maybe it's 3 or 5 or something. So it will tell you the top k classes and their probabilities and labels itself. And then we detach the variables. So detaching variable is done to make sure that the gradients do not back propagate with that particular variable. Okay, top props dot detach. Okay. Use the zeroth value, then top labels. Okay, top labels. We detach both of these variables. Okay, detaching variables. Now, after finishing all this, we just need to check the dictionary itself. So dictionary is in the form of, say, the class and the probability assigned with it, but we need we need it to be reversed because we have probabilities and we want to know the particular class of that probability, right? So we have to reverse the dictionary. So for that you can use a for loop. I am doing something like that using a simple class, simple line manner, using it the Python function for running the for in a single line, for loop in a single line, right? So let's write it like this: key for key, okay, key and value, and model dot class idx dot items, right? Now use the reverse dictionary to get the table, right? So top labels would be just using idx to class that we defined here, the diverse dictionary, and using the uh, index that we are using for all the probability, all the top labels that we got. Okay, index to class, say lab, for lab in top label. So we check the top labels, And so we check the top labels, and then we get the top probabilities associated with it and the top classes, and now we just need to return, right, top props and top labels. So that's all for the predict part. This we will be using directly in our predict.py, right? So many of you might find it useful because till now we had only done till testing part. We did not cover the part where we predict for a single image. So this is where can use that. Okay. um okay, so I'm not gonna run this because for that I need to run this whole program again. I ran it last time a while back. So yeah, so we'll keep this right now. Okay, it will be saved automatically, I guess. And now we will just go to the command line then. Okay, so let's go to the command line part. Yeah, yeah, so arcpass tutorial is here. You can use this to understand it. Okay, so I'm gonna make use of this thing in the second part. So workspace is clear. All of this is covered, right? So starting from beginning, loading data is covered, right? How you load and use the transforms. Label mapping is also done. Building and training and classifier I also covered this in the last video. You can check that out. Testing is also done. Saving checkpoint, loading checkpoint is also done. Image processing is already done here. uh, so I am sure this is done for showing the image. And now the predict part I have also covered. So just copy that function here, right? Just copy this part here, and this will make you the, let me just keep this as it is and paste it here. Okay, so now this completes your project using the model, also using the predict part also. Now you can display the image with top key classes. Okay, so yeah, now let me go back to the command line app. Okay, yeah, so it takes some time to load. My internet connection is quite slow. Maybe it will work better in your systems. Okay, so this is all that we had, and now we are going to the command line part. Okay, it's taking quite some time to load. I don't know why. Okay, now it has loaded. Okay, so you see, this is my image classifier file. I have train.py and predict.py. If I'll write a, small file, let's call it my main.py. Okay, so this I'll use to call the functions from predict train py and predict py. Okay, so earlier we also had this. If we did define this, okay, in this you change to the image classifier directory, press tab, and it will go there by itself. Then you try to run it, python train.py, pass it some argument, hello world, yeah, and it will print the arguments itself, right? So now in this part of the code in train.py, you will be taking out the training blocks here, right? This block, training block, and you will be pasting it here. Okay, uh, and it will be run using the command line arguments. So here we already have defined the train data directories and all those things. That will not be necessary here because those will be passed as arguments. So basically the core functions will remain the same, just a slight modification in the way how data is read. Okay, um, yeah, so I'll just make this main.py and try to show you. Okay, so let's see if I do ls. So I have all these files main.py, right? So let me first then, okay, use the libraries, copy all the libraries then first. Okay, right, and here, since this is a main file, I'll be writing this in a form of main function like we usually do in Python. If name equal to main, right? So now this function will run first. So now I'll be making use of this arc pass thing. So you can just go through this and how this is done. So I need to import the arc parse. Okay, so arc parse. Now parser equal to, so this I know from this way, parser equal to arc parse dot argument parser. I will use it in the form of default. Okay, done. Now let me add some arguments to the parser. This is also there in the tutorial. You can check it out, right? So now first let me define my mandatory argument or default argument here. Okay. So my default argument or some is something that I need to pass it anyhow. Okay, so here I'll be passing the data directory, and then in the train function what you can do is you can use an if statement, and then you can say that for this data directory use the one that I am getting from the argument. So argument you can use from this sys.argv, and then use the indices. Okay, and then the training part can use that particular data directory this way. So now let me go back the main.py. I define data directory. Right. So basically it is for replacing data directory thing, right? Now let me add some optional argument. Okay, optional arguments work like this. So you say the save directory, right? And you define the type. So here the type is string, and then you say, okay, so this was something I read here. Help. Okay, help. Help is for telling you what does it do. Okay, so let me define it. Help equal to directory save your model. So what function will be using this save directory command? The save directory command will be used by our save model function. Okay, so this I have defined here as save model function that takes model, the file name where it has to be saved, and the indexes class, and then it just saves it checkpoint and the model itself in the save directory. Okay, now so now it's done. Let me go back there. Okay, so we have save directory, we have data directory, and there were some few arguments more. Okay, so there was GPU one also. Okay, so I'll just copy the same lines as above. AP dot argument here, instead of writing save directory, I'll be writing GPU. Type will be same as string, and here in help I'll be writing that. So here I won't be needing is GPU. I can write GPU command. Okay, and then there is something called as action. So you may find it here as well. So action here is it is telling me that if I use this, it will set the default value as true, otherwise false. So let me use action equal to store to. Done. So this is also done. Now I will pass all the arguments like this way. Yeah. So this I can also show you. Here is this args equal to parser dot parse args, right? So this I will use. So here they are using a result. Let me use this. Okay, so now all the arguments are there in the arguments, and now we can call whatever we need to call from here. We can call train for pi, p predict pi, anything, right? So first now that then define the data directories as well. Okay, data directory equal to args dot data, right? So it may not be in the main function. So now I have put all the arguments in the args variable. Now from args I take out my data directory. Okay, I can take out my save directory, args dot save dir, and I can use my GPU mode equal to args dot GPU, right? And now I can just print it. Okay, print data directory, save directory, and GPU. Okay, so yeah, it should be saved automatically. Let me try to run it then. Python main.py. So what are the arguments? Data directory. Let me say home. Okay. After this, save directory. Let it also be home. And after this, GPU. Let me set GPU as. Okay. Okay. So it's matplot. This is not needed here. Has no attribute argument parse. Okay, so should work. Maybe there is some spelling mistake. Art parse has no attribute argument parse. Okay, so it's not argument parse, it's argument parser. No attribute art argue. And okay, yeah, there is again spelling mistake. S- Yeah, if the terminal looks too much, then you can write clear. Okay, so what was the error earlier? So let me try it again. So maybe there are some few spelling mistakes here and there. Has no argument. Okay, so there is again spelling mistake. Hold on. Type, okay, in line 16. So it's not needed here. Start GPU. Print is not defined. Right. So you see, now it is working quite well. Let me show you again. So there was few spelling mistakes here and there. Now it's working fine. It is telling me the data directory is this, save directory is this, GPU mode is this, right? So using this way, you can change your now. What you need to do is you have this data directory here, right? Now go there and see what how were we training, right? We're training. We were making train loader using that data directory, right? So so now we, instead of this data directory, we have that one. Now we can copy paste all of this as it is, right? So now, so it's quite slow. Okay, so now instead of that data directory, the one we were using data dir, so data dir is now this one that I have passed from my argument. Okay, so now this will be using that one to create train loaders. Okay, and then you can again copy paste, right? Again copy paste those trading blocks, and it will run perfectly fine. I won't be running it because it will take quite a long amount of time here, but you get the idea, right? So you just need to pass the arguments as such, and now you can change it to any you can change the default arguments that you were using earlier by extracting out values from this parser. Okay, now, so if that's done, so we have also added transforms here. Now there was one thing about accuracy. Okay, so accuracy we also did in last part. So in prediction, what we can do is, mm, so let me create the train file here. Okay, let me just copy the whole thing. Okay, now what what do we need and what we do not need? Okay, so let's put the main function at the end. So this we can extract out. Make my terminal a little small. Yeah, just take care of the indentation. I make many mistakes in indentation. Make sure you do not. Okay, now So I have these things and all that. So would it be running the training? After passing these arguments, I can call a function, uh, run train. Okay, pass tasks and def run train would be like this. Run train. Now all this I can put here. Okay, let me check. Correct the indentation first. Okay. So now this run train, what it does is it takes arguments and sets the data directory, saved directory, and GPU modes, and now it can just call training deep network. Let me check. Let's go down. Okay. Now it can call training deep network, pass train loader in it, and then number of epochs. Let's say 10. Okay. So this concludes our training file basically. So this was all that was needed, right? So that's all you need to do in training. And in prediction also, I can do same kind of stuff, right? Just control copy paste in the prediction file. Now I do not need the train function, right? I can use however the train run train function. Instead of run train, it will be run prediction. Okay, so above it I can use this. So now I am not using training deep network. uh, all this stuff is not needed now. It's there in the run train function. Run train function can be changed to run prediction function, right? And similarly, the argument in the prediction was something different. It was like predict the image path, right? So you can pass that image path there, and we already have defined our prediction function. Okay, we just copy paste this part and put it here above it. Okay, so where it is, yeah. So so now we have predict function. We run the run prediction and call it from predict. We pass the image path, saved model top k. So you see, this you can also add like parser or add argument, right? Image path type equal to str, help equal to directory for single image path, right? Similarly, parser dot add argument. Now we were also using something else in image path, saved model. Yeah, saved model. So this is already there in the saved directory. Okay, so you don't need to do this much. That will work fine. So you have, okay, let me check. So the system, yeah. So now how you do is you have the arguments, you save all those arguments in args. Using args you can extract out different variables, the directory paths, the parameters, the hyperparameters, whatever you need, and then you can pass it on to the main function, right? So here in the training we did was we first apply the transformations that are needed in run training, and the also pre-processing of the image we can also do there. Okay, so there is also one function called check accuracy. I don't know which part it was in. Was there somewhere check accuracy? So in last video I also made a function called check accuracy that you can also paste here in the predict part, right? Yeah, so that pretty much sums it up. So we covered all the parts. Already we have discussed how to make the whole project using the different code blocks that we have made in the exercise, and how to assemble them to create the whole project. Now we have also discussed how to use the command line arguments. So this tutorial is pretty much it. This is good and enough for this small exercise. You can use this one and then see this tutorial also for this command line thing, right? You just need to put your material here, the code you have done here, and for the all the variables, all the arguments that it needs, you need to use command line. Okay, so this will run fine. Yeah, so that's all for it. Okay, so it was not a quite a long session, but we discussed quite a lot of things. We discussed the predict function that we have to use in the second part. So predict function takes the directory and tells you the performance of top k classes um, for that particular flower entry. And then we also learned how to use this in the command line fashion. So just to complete the whole project. So many of you have submitted and the project is accepted. So it's not that hard. It's like so if you have done all the exercises earlier, it's not more than 2 to 3 hours of work, and rest of the time will take some time in the training and stuff. It's quite slow. I have also tried to do it from my side. It's quite slow on my system. So I lose the patience for doing it, and then my workspace also by sitting idly for a long time, it just shuts off. Okay. Yeah, so that pretty much is up for today. So thank you for this. Thank you for watching this session. If you watch it for your doubts, okay. So do watch it, and after this, you will be able to submit your project quite well. Okay. So yeah. Okay then. Goodbye to all of you.